Hello students, welcome to All Force e-learning channel. This is K. Nageshwar Rao, your physics faculty. Today we are about to deal with the session number 95, second year Neet physics. In the last session we have dealt with Wheatstone bridge principle. We have come to a conclusion, P by Q is equal to R by S. When the bridge is balanced, the relation between the four resistances that we have taken in the Wheatstone's bridge, what is that relation? P by Q is equal to R by S. That was our conclusion. And we have verified with one simulation whether this is truly possible or not when you deal with one such kind of circuit practically. Okay, so is it possible or not? Okay, possibility in the sense when P by Q is equal to R by S, really won't be any flow of current in the diagonal branch or not. We have verified that, isn't it? And later we have seen few forms of Wheatstone bridge. In different forms it can be drawn, isn't it? So those forms we have seen. So let us proceed with few other details connected with the Wheatstone bridge. So what was the bridge circuit that we have drawn yesterday? We have taken four resistances, something like this. These four are named as P, Q, R, S, and here one galvanometer is connected. Okay, so this is what roughly the circuit that we have used to understand Wheatstone bridge principle, and this is what we call it as Wheatstone bridge. Okay, so let us say current I is passing through this one. Potential supplied here by the battery is V. I'll assume it like that. And what was the conclusion when the bridge is balanced? Bridge is balanced in the sense there is no any current through this branch, a diagonal branch. There is no any current through galvanometer. Okay, if there is no any current because potential at this point B, I'll designate these corners with some letters A, B, C, D. So potential at point B is equal to potential at point D. When the bridge is balanced, if that is the situation, there won't be any current flowing in this one. So IZ will be 0. If IZ is 0, immediately followed by that, what was our conclusion yesterday? P by Q is equal to R by S. So this is what our conclusion was. Okay. Now, let us try to understand this a little bit more. Here, what happens if you replace these resistances with the capacitors? Already electrical capacitance was discussed in the previous sessions. Okay, so if you replace these circuit elements with the electrical capacitors like C1, C2, C3, C4, four capacitors you have taken, something like this. I'll draw the circuit for you. Something like this. C1, C2, C3 and C4. Let us say this is how it is connected. This network is connected to the battery. This is also called as Wheatstone bridge with the capacitors. So if the bridge is balanced in the presence of capacitors, then also what you can write in place of P, what we have C1, in place of Q, what do we have C2, R C3, S C4. So when the bridge is balanced, what you can write C1 by C2 is equal to C3 by C4. So that's how you can make use of Wheatstone bridge principle to handle capacitors related circuits as well. Okay, so if you see any in such kind of circuit, let us say some other capacitor is placed here. Now it's quite difficult to identify which set of capacitors are in series and which set of capacitors are in parallel combination. We cannot find. So if at all, if you have identified that C1 by C2 is equal to C3 by C4 in this case, let us say this is C. Okay, if C1 by C2 is equal to C3 by C4, what does it mean? The bridge is balanced. What does it mean? There is no any current passing through this one. What does it mean? Potential at these 2 points is same. So if there is no any current passing through this one, you can remove that one. You can ignore that. Its presence in the circuit has no meaning. So you can remove that. Once you remove that, these two will come in series combination. These two will come in series combination. The upper branch comes in parallel combination with the lower branch. Now you can handle the situation. You can find out effective capacitance or whatever he is asking for. Okay, so that's how you are going to write the Wheatstone bridge principle in terms of capacitances. Okay, so what after the bridge is balanced, what we have done, we'll remove that with this one. If it is removed, what scenario we see here? We see that P and Q are in series combination, R and S are in series combination, and this upper branch totally in parallel with the lower branch. So if I redraw this one, how the circuit can be redrawn? The circuit can be redrawn something like this. This is what? P plus Q. The upper resistance is P plus Q. The lower one is R plus S. This is connected to the battery. This is what equivalent resistance, equivalent circuit. Okay, so here P plus Q, both are in series, no? So you will take effective resistance as P plus Q. So that is replaced with one single resistor whose resistance is equal to P plus Q. Similarly, in the bottom also replaced with R plus S. Okay, so in this case, since these two are in parallel combination, we know that if two resistances are in parallel combination, effective resistance Rp is written as R1 R2 by R1 plus R2. That's how we write. Here R1 is what? P plus Q. Therefore, in this case, effective resistance is equal to R1. R1 is nothing but P plus Q into R2 is nothing but R plus S, R1 plus R2. So in the denominator, what you will have? Sum of these two resistances, P plus Q plus R plus S. So that's how you are going to handle the effective resistance when you have come to know that the bridge is balanced. Okay, and one more thing. Here we need to talk about the sensibility. Sensibility in the sense, even see, when this kind of relation P by Q is equal to R by S is possible, what do we see here? We see that there is no any current passing through the galvanometer. Whatever galvanometer we have arranged here between B and D, we see that there is no any current passing through the galvanometer. So the galvanometer is supposed to be very sensible. Very sensible in the sense, even for slight variation in the resistances or slight variation in the currents, immediately it should respond. That's what we call it as sensibility. Okay, so here sensibility of the network will be very high when all these resistances are equal. If P is equal to Q is equal to R equal to S, then sensibility will be very high. Sensibility is very high in the sense, it's like, very quickly you will be able to see the condition of bridge balanced condition can be seen very quickly. Okay, so for the sensibility of for high sensibility, P is equal to Q is equal to R is equal to S. For example, if you are having 1 ohm here, 2 ohms here, 1 by 2. Okay, and here let us say you are having 2 ohms and here 4 ohms. So P is equal to what? 1 ohm, Q is equal to 2 ohm, and R is equal to, let us say, 2 ohm, S is equal to 4 ohm. Now, P by Q, is it equal to R by S or not? Yes, it is equal. P by Q is how much? 1 by 2, and R by S is also how much? 2 by 4, which is equal to 1 by 2. So P by Q is equal to R by S, isn't it? But in this case, when the sensibility won't be that much when compared to this case. Which case? P equal to Q equal to R equal to S. For example, if P is equal to 2 ohms, which is equal to Q, which is equal to R, which is equal to S. If that is the situation, there will be high sensibility. High sensibility in the sense you see a very quick response from the circuit. Okay, very quickly you see the balanced, balancing condition. Sometimes it happens, whatever ammeter, whatever galvanometer we have here, it may not respond so quickly. Okay, its response will be very quick if you are having this kind of condition, if all are of same resistance. Okay, so these are certain key points connected with Wheatstone bridge. And this kind of arrangement is called a Wheatstone bridge. In Wheatstone bridge, what is happening when the bridge is balanced? Bridge is balanced in the sense potential at this point and potential at this point D both are same. Okay, then what happens? You will have this kind of condition, P by Q is equal to R by S. Or if P by Q is equal to R by S condition is possible, then you can say that potential at point B, potential at point D are same, or there won't be any current passing between B and D. Okay, vice versa. Okay, so what if potential at point B and potential at point D are not same? It means there is some potential difference. If there is some potential difference, there will be current between these 2 points. If you connect a resistor here, for example, okay, when the bridge is balanced, what is the situation? Potential at B and potential at D both are same. So though you place something, if you connect a resistor between B and D, will there be any flow of current? No, there won't be any flow of current because these 2 points are maintained at the same potential. Okay, what if these 2 points are not at same potential? If these 2 points are not at same potential, it means there is some potential difference, right? So if you connect a resistor between these 2 points, what happens? There will be current flow. And what do we say? We say that the bridge is not balanced. It's not balanced. So if we are dealing with unbalanced bridge, how to find out effective resistance? If we are dealing with unbalanced bridge, from where to where current will flow? from B to D current will flow or from D to B current flows. These things we can explore. Okay, let us see. So let us say the bridge is not balanced. What kind of bridge is this? Unbalanced Wheatstone bridge. Unbalanced Wheatstone bridge. Okay, unbalanced Wheatstone bridge in the sense potential at point B and potential at point D are not the same, they are different. So there is some potential difference. So let us try to find out how much is that potential difference, and later we will be able to find out whether the current flows from B to D or D to B. If at all, if we come to know that potential at B is more when compared to D, obviously current flows from B to D. If we came to know that potential at D is more than potential at B, it means current flows from D to B. High potential to low potential. Always current flows from high potential to low potential. So let us say a current I is entering here. Let us say into this branch I1 current is entering, and into this branch let us say I2 current is entering. Okay. See, we know that if we wanted to find out this I1 current which is flowing through the upper branch, what we can do, we can use this formula. I1 is equal to, this was already concluded when we have dealt with the parallel combination of resistors. I1 is equal to I into R2 by R1 plus R2. Similarly, I2 is equal to I into R1 by R1 plus R2. And in the present situation, what is R1? R1 is upper branch resistance. Upper branch resistance is how much? Tell me. P plus Q. And lower branch resistance is how much? R2, which is equal to how much? R plus S. So R1 is equal to P plus Q and R2 is equal to R plus S. So with this idea, we'll try to proceed. Okay, I'll take potential difference between these 2 points A and B. How it can be written? VA minus VB. So this is what? Potential difference between A and B. VA minus VB. This potential difference can be written as using Ohm's law. How it can be written? Potential difference is equal to current multiplied with the resistance. How much current is flowing between these 2 points I1, and how much is the resistance between these 2 points P? So how it can be written? I1P. And I1, just now I have written here, what is I1? I1 is I R2 by R1 plus R2 into P. And what is our R1 and R2? I have written here, see. So finally what we can conclude, I into R2 is how much? R plus S into P divided by R1 plus R2. If you add these two things, what you will get? P plus Q plus R plus S. So let us take this as equation number 1. Okay. Similarly, let us try to find out potential difference between point A and D. VAD. I'll write it as VA minus VD, which is equal to how much? Current passing through this branch is I2 multiplied with resistance between these 2 points. How much is the resistance between these 2 points? R is equal to I2. How this I2 can be written? I R1 by R1 plus R2 into R. Okay. What is our R1? P plus Q. So I into P plus Q into R by R1 plus R2 is P plus Q plus R plus S. Let us take it as equation number 2. And what is our interest? I wanted to find out potential difference between V and D. So VB minus VD or VD minus VB, whatever it is. So let me subtract equation 2 from equation 1 from 2. Okay, subtract equation 1 from 2. 2 minus 1. So what do we get? So VA minus VD minus VA minus of minus plus VB. VA gets cancelled. So finally what you will have on the LHS side, VB minus VD is equal to, and here you are subtracting this one from this one, isn't it? See the denominators, P plus Q plus R plus S. Here also P plus Q plus R plus S. So LCM will be P plus Q plus R plus S. So subtract the numerators, subtract this numerator from this numerator. What you will get? I of P plus Q into R minus this one, I of R plus S into P divided by P plus Q plus R plus S, isn't it? So let us simplify this equation and see what do we get. I can take out I common. So if I is taken out, VB minus VD is equal to, what you will have? I into PR plus QR minus RP minus into plus minus SP, right? So in the denominator what you have? P plus Q plus R plus S. Now PR, RP both gets cancelled. So finally this is what the conclusion is. I into QR minus SP by P plus Q plus R plus S. This is nothing but potential difference between point B and point D. Point B and point D. So let us try to understand this equation. Here, whether this potential difference, is positive or 0 or negative, it depends on what? It depends on QR and SP values, isn't it? So what if at all if the bridge is balanced, how do we write? We write it as P by Q is equal to R by S, isn't it? For example, if QR is equal to SP, what does it mean? That implies P by Q is equal to R by S, isn't it? P into S, this one, R into Q, this one, not Q into R, isn't it? So if you are having QR is equal to SP, both these two terms gets cancelled, and on the RHS side what you are left with? You are left with 0. That implies VB minus VD is equal to 0. That implies VB is equal to VD. So potential at point B and potential at point D are same when QR is equal to SP, isn't it? If potential is same, there won't be any current flow between point B and D. It means bridge is balanced. So bridge is balanced when QR is equal to SP. That is nothing but P by Q is equal to R by S. What if QR is not equal to SP? What is the other possibility? If QR is greater than SP, QR is greater than SP, then this numerator value will be positive. If numerator is positive, what does it implies? That implies VB is greater than VD. See here, P by Q is equal to R by S condition is not possible because QR is greater than SP, isn't it? So if QR is greater than SP, this numerator is positive. This numerator is positive. VB minus VD is positive. VB minus VD is positive in the sense VB is greater than VD. So potential at point B is greater than potential at point D. It means current flows. If at all, if you connect a resistor between these 2 points, current flows from point B to point D. That implies current flows from B to D. The other possibility is if QR is less than SP, what happens? The numerator will be negative. QR is less than SP. Okay, QR is less than SP. So it becomes negative. It means VB minus VD is negative. What does it mean? VB is less than VD. That implies VB minus or VB is less than VD. That's what you can write, isn't it? So if VB is less than VD, so it is at low potential, it is at high potential. So in this case, current, if at all, if you connect any resistor between these 2 points, current flows from D to B. That implies current flows from D to B. So that's how you can deal with an unbalanced Wheatstone bridge. This is what basically Wheatstone bridge, and this is how you can handle unbalanced Wheatstone bridge. Okay, so let us try to find out a way to deal with effective resistance calculation if you are having unbalanced bridge. Okay, so let us see. So let us deal with this case. Equivalent resistance in case of unbalanced Wheatstone bridge. As you see here, this is not balanced. P by Q is equal to what here? P by Q is equal to R by R. What is R by S? R by S is equal to capital R by, here in place of S, what do we have? Small r. Small r by capital R. Is it equal to capital R by small r? It's not equal. So P by Q is not equal to R by S. So the bridge is not balanced. So it's obvious. So in this case, if you are supposed to find out the equivalent resistance between points A and B, how to find out that? So let us say in this circuit, a total of current I is flowing. How much current is flowing? I is flowing. Let us say the potential difference between point A and point B is V. So I'll assume that here, let us say potential is V, and here the potential is 0, 0 volts. Here V volts. Okay, that's how I assume. Now, let us try to write equation of equivalent resistance. How it can be written with this known data? Total potential difference between point A and point B is how much? V, isn't it? And how much is the total current flowing through the circuit? I. So therefore, R equivalent can be written as V by I, isn't it? R equivalent is equal to total potential difference between A and B divided by total current flowing between A and B, V by I, isn't it? So if we can manage to find out this I, let us say when this I value of current is entering here, into this branch, some current I1 is entering, and here let us say some I2 current is entering. So that I will be what? I1 plus I2. Okay. So like that we'll try to replace that I, okay, properly. Okay, to handle this situation, what I'm going to do is I'll assume that at this point, let us say this point is A, this point is B. Let us say here the potential at this junction potential is X. Here potential at this junction is Y. Okay. Now, if I apply KCL, Kirchhoff's current law, or Kirchhoff's junction law, okay, I'll call this junction as junction 1, this as junction 2. This is X is what? Potential at this point, or potential at that junction, and Y is what? Potential at junction 2. Okay, applying KCL at junction 1. So according to Kirchhoff's current law, what? Current entering the junction is equal to current leaving the junction, or algebraic sum of the currents meeting at a junction is equal to 0, isn't it? Or current entering the junction is equal to current leaving from the junction. So I'll make use of this algebraic sum of currents being 0, mathematical form of KCL. Okay. So let us try to write what the current between, current entering into this junction. Let us try to understand. Here current is possible between point A and this point, and current is possible through this resistor, and through this resistor also current is possible. And according to Ohm's law, if you wanted to write current, how do you write? Current is equal to potential difference by resistance. And what is the potential difference between A and this point? Here potential is V volts, here potential is X. So the potential difference can be written as X minus V by how much is the resistance here between these two potentials? R. Okay, plus through this branch also there will be current. So potential difference is how much? X minus Y by R. Through this branch also there will be current. How much is the potential? Here potential at this point is 0. Here potential is X. So X minus 0, X. So plus X by how much is the resistance between these 2 points? Capital R is equal to 0. According to KCL, algebraic sum of all the currents is equal to what? 0. Similarly, at junction 2, also let us apply this KCL. What you can write for current between these 2 points A and this junction 2, what you can write? Potential difference. You have to take potential difference divided by resistance. Potential difference is Y minus V. Potential at this point is V. Potential at this point is Y. Divided by how much is the resistance between these 2 points? Capital R. So potential by resistance gives us current. Plus potential difference between these two? Y minus X by how much is the resistance? R. For writing these things, I am taking this potential as a reference. Okay. So what about this branch? Plus here potential is Y, here potential is 0. So Y minus 0, Y, and between these 2 points, how much is the resistance? Small r. So Y by R is equal to 0. So like this we have two equations. Here capital R and small r are known to us. What we don't know is we don't know X and Y. We don't know X and Y. We even know this value V also. Okay. Whatever situation I have described here known values are what? Small r, capital R, and this V. These things are known to us. What we don't know is X and Y are unknown. Potential at this junction and potential at point Y, they are unknown. So now we have two equations in terms of x and y. Can't you solve these two equations to get the values of x and y? There is a reason for looking for x and y values. You know, this equation, I'll take it as 1, I'll take it as 2, I will take this equation as 3. Equation 1 can be written as R equivalent is equal to V by, see here, finally how much current comes out? I value of the current comes out, isn't it? So here, this I value of current, how you can write? You can write it like this, see, between these 2 points, let us say some I1 current is, reaching this point, and between, Y, or between junction 2 and between point B, let us say I2 current is flowing. So this I1 and I2 both will meet here and they will add up to give I value of the current. So here whatever I is there in the denominator, this I can be replaced with I1 plus I2. So further how this I can be written, current is equal to potential divided by resistance. How much is the potential which is driving this I1? Potential difference between these 2 points is driving I1. So how much is that potential difference? X minus 0. So X by, how much is the resistance here? Capital R. Plus, what about I2? I2 current is driven by potential between this junction 2 and this point B. At junction 2, potential is Y. At this point B, potential is 0. So potential difference is Y minus 0. So Y is the potential difference divided by, how much is the resistance? R, small r. Now, you have to find out X and Y values from these two equations. You can solve this, when you keep on simplifying this one, you'll see several equations, but once you simplify, you will get the values of x and y, and if you replace here values of x and y, finally, whatever v term comes out here in these equations, v term is there, right? So you can get rid of that v, and finally we'll be left with R equivalent as R into 3R plus R by 3R plus R. So this is what the equivalent resistance expression in case of unbalanced bridge. For example, let us say we have a unbalanced bridge, something like this. Here you have, let us say 2 ohms, here 3 ohms, okay, and here 2 ohms, here also 2 ohms, here 3 ohms. P by Q is 2 by 3, R by S is 3 by 2. So obviously 2 by 3 is not equal to 3 by 2. So this is unbalanced bridge. So if this is the situation, and if you are supposed to find out R equivalent, so this is how you have to find out. In place of small r, what do we have? 2 into 3. Capital R is how much here? 3. Plus small r is 2 divided by 3 into small r, which is 2 here, plus capital R, which is 3 here. So 2 into 3 3s are 9, 9 plus 2, it's 11 by 3 2s are 6 plus 3 9. So finally the answer is 22 by 9 ohms. So that is the effective resistance between these 2 points A and B in case of unbalanced bridge. Okay students, so now let us try to solve few problems connected with this. Now let us try to solve these problems. In the first question, what is given? In the given circuit, current through the galvanometer is. So when circuit is given, we have to find out current through the galvanometer. See children, if you are supposed to find current through the galvanometer, you should know how much resistance the galvanometer possesses, isn't it? If you can manage to find out potential difference between these 2 points, okay, you should know what is the resistance offered by the galvanometer. Then only you will be able to find out current passing through the galvanometer, isn't it? And that, before that, what you have to check? You have to check whether the bridge is balanced or not. Okay, P by Q 6 by 3 is how much? 2. R by S 3 by 6 is 1 by 2. So P by Q is 2, R by S is 1 by 2. So bridge is not balanced. If bridge is not balanced, so here what is the situation? P by Q is not equal to R by S. Okay, so let us try to find out from where to where the current flows. Okay, so actually in this question, the only possibility is you can identify from where to where the current flows, whether the current flows from point C to D or from D to C. That's what you can find. Okay, and we came to know that this is unbalanced bridge. If at all, if you have to find out current through the galvanometer, you should know how much resistance the galvanometer is offering. That is not given. So the only scope in this situation is you can conclude whether the current is flowing from C to D or D to C, isn't it? Because potential difference is there between these 2 points, because P by Q is not equal to R by S. right? So this is the equation that we have derived earlier. So potential difference between these 2 points can be written as a total current multiplied with QR minus PS by P plus Q plus R plus S. Okay, so here what is P? P is 6 ohms, Q is 3 ohms, R is also 3 ohms, S is equal to 6 ohms. So these are the details known to us, right? So let us check QR. QR is how much? Q into R, it's 3 3s are 9 ohms, and PS is how much? P into S, 6 6 are 36 ohms. Obviously QR, which is 9 ohms, is less than PS, which is 36 ohms. So if QR is less than PS, this VC minus VD will be what? It will be less than 0. It will be less than 0, or it will be negative. It will be negative. If it is negative, what does it mean? That implies VC is less than VD. VC is less than VD. It means C is at low potential and D is at high potential. So current will be from D to C. If any current is there through the galvanometer, that will be from D to C. Therefore, current flows from D to C. So that's what conclusion we can draw here. See the next question. The resistance between A and B is, so between A and B, we have to find out the resistance. So before starting this, you need to check whether the bridge is balanced or not, or before that you have to identify whether this is Wheatstone's bridge or not. Yes, it is Wheatstone bridge only. You have to check whether the bridge is balanced or not. Here, what is P? P is equal to 4 ohms. Okay. Q is what? This entire resistance, so 2 plus 2. How much is that? 4 ohms. What about R? R is this entire resistance, 2 plus 2, 4. R is also 4 ohms. And S is also 4 ohms. Yes, P by Q is equal to R by S. So the bridge is balanced. If the bridge is balanced, what is the effective resistance equation? R effective is equal to P plus Q into R plus S by P plus Q plus R plus S. We have seen this one, we have derived that, is equal to P, Q, R, S, all are 4 ohms only. So what you can write, 4 plus 4, 8 into 4 plus 4, 8, 4 plus 4 plus 4, how much? 16. So what you will have? So 4 ohms is the effective resistance. So how much is the effective resistance? 4 ohms. Okay. Now let us see this third question. Equivalent resistance between A and B in the given circuit. See this circuit once. It's a Wheatstone bridge only. But is it balanced or not? Let us check that. Here what is P? P is equal to 10 ohms. Q is equal to 20 ohms. P is 10, Q is 20. And R is equal to 20 ohms. S is equal to 10 ohms. Now tell me, P by Q is how much? It's 10 by 20, 1 by 2. What about R by S? R by S is equal to 20 by 10, which is equal to 2. So P by Q is not equal to R by S. It means the bridge is not balanced. If bridge is not balanced, and if you are supposed to find out the equivalent resistance between A and B, we have already seen one equation, we have derived that. Okay, so what was the equivalent resistance? Its equation is what? Small r into 3r plus r by 3r plus r. So this is what our conclusion was earlier, okay, in the previous slide. So here what is small r and what is capital R? Small r is 10, capital R is 20. So let us replace here. Small r is what? 10. Capital R is 20. So 3 into 20 plus 10 divided by 3 into 10 plus 20. So what you will get? 3 into 20, 60. 60 plus 10, 70. 70 into 10, 700. Divided by, in the denominator what you have? 3 into 10, 30. 30 plus 20, 50. So finally, what is your answer? 5 ones are and 5 fours are. Okay. So the equivalent resistance between point A and point B is how much? 14 ohms. See this fourth question. For what value of unknown resistance X? Here it is. Here it is. For what value of unknown resistance X, the potential difference between B and D will be 0. Here he is asking about potential difference between B and D being 0. Okay. So when potential difference between B and D will be 0? If the bridge is balanced. We know that potential difference is 0 in the sense potential of B and potential of D both are same. Potential at B and potential at D will be same when it is possible, when the bridge is balanced. So if the bridge has to be balanced, P by Q must be equal to R by S. What is P here? Let us try to identify. P is equal to 12 ohms and Q is equal to, here 1 ohm resistors were taken in parallel combination. In parallel combination, what is the effective resistance? R1 R2 by R1 plus R2. 1 into 1 by 1 plus 1. How much is that? 1 by 2. 1 by 2 ohm. And similarly here, what about R? R is equal to, these two resistances are in series. So the effective value will be X plus 6 ohms. And S is how much? Again here also 1 ohm resistors were taken in parallel combination. So S is also equal to 1 by 2 ohms. So now we have identified what the P, Q, R, S values are. And it was already mentioned indirectly in the question that the bridge is balanced. Because he is talking about, potential difference between B and D will be 0, isn't it? That is possible when the bridge is balanced. If bridge is balanced, P by Q is equal to R by S, isn't it? Since bridge is balanced under given condition. What condition is given here? Under this condition it is balanced. So P by Q is equal to what? R by S. That implies P is how much? 12 ohms. P is equal to 12 ohms divided by Q is how much? 1 by 2, which is equal to R is how much? X plus 6 divided by 1 by 2. 1 by 2, 1 by 2 gets cancelled. So X is equal to 12 minus 6, which is equal to 6 ohms. So what should be the value of X so that the potential difference between B and D will be 0? X should be equal to 6 ohms. Then potential difference between B and D will be 0. Okay. So this is where I will conclude, and will proceed with a few other applications connected with the Wheatstone bridge, okay, in the next session. Thank you, students.